Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan Iqbar. I'm majoring in management. In this video, I want to give you an explanation of basic of matrix operation, transposition, addition and subtraction, scalar multiplication, and matrix multiplication. What is a matrix? Matrix is a rectangular array of numbers, symbols, or expressions that are arranged in rows and columns. Matrix is called matrices in plural, and matrices are commonly written in box brackets with horizontal and vertical lines that are called rows and columns. A matrix has m rows and n columns, that is called an m by n matrix, while m and n are called its dimensions. The dimension of the following matrix are 2 by 3 because there are 2 rows and 3 columns. The individual items like numbers, symbols, or expressions in a matrix are called its elements or entries. Provided that they are the same size, like have the same numbers of rows and same number of columns, two matrices can be added or subtracted element by element. This is an example of matrix. The next is a transpose. What is a transpose? Transpose of a matrix is an operation that turns the rows of a matrix into the columns of the resulting and another interpretation. This is we would say A, and this is we would say A transpose. So the transpose is a reverse the dimension, in particular this matrix. And the next is adding and subtraction matrices. In order to do this, the entries must correspond. Therefore, addition and subtraction of matrices is only possible when the matrices have the same dimensions. Matrix addition is commutative and is also associative. So the following this. Adding matrices is very simple. Just add each element in the first matrix to the corresponding elements in the second matrix.
Now the element in the first matrix is 1, adds to element x1, 1 in the second matrix 10, to produce element x1, 1 in the resultant matrix 11. Also now that both matrices being added are 2 by 3, and the resultant matrix is also 2 by 3, you cannot add two matrices that have different dimensions. And the subtracting works much the same way except that you subtract instead of adding.
And the next is scalar multiplication. In an intuitive geometrical context, scalar multiplication of a real Euclidean vector by a positive real number multiplies the magnitude of the vector without changing its direction. This is an example of scalar multiplication. The resulting matrix has the same dimensions as the original. Scalar multiplication has the following properties like this. And the last is matrix multiplication. Matrix multiplication is multiplying every element of each row of the first matrix times every element of each column in the second matrix. When multiplying matrices, the elements of the rows in the first matrix are multiplied with corresponding columns in the second matrix. This figure illustrates diagrammatically the product of two matrices A and B, showing how each intersection in the product matrix corresponds to a row of A and a column of B. Here is an example of matrix multiplication. Start with producing the product for the first row, first column element. Take the first row of matrix A and multiply by the first column of the matrix B, the first element of A times the first column element of B, plus the second element of A times the second column element of B. Continue the pattern with the first row of A by the second column of B, and then repeat with the second row of A.
I'm sorry to forgot to take a clip of closing in this video. That's all that I could say anyway. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.